Hey everyone, where is the math in this problem? How much 40% rubbing alcohol do we need to add to 90% rubbing alcohol to make 10 liters of a 50% solution of rubbing alcohol? You can pause the video and find where's the math in this problem. Now let's solve this problem together. The first step is for us to assign variable to the unknown. But before we are able to assign the variable, we need to organize first our given into a form that is easy for us to understand. And in my experience, I usually use tables and charts to organize the given. So what do we have here? We have different types of mixtures. We have a solution that is 90% rubbing alcohol. We also have another 40% solution and our desired solution of 50% rubbing alcohol. Then, we write the strength of the solution in decimal. So 90% is 0.90, 40% is 0.40, and 50% is 0.50. Then, we identify the volume in liters of each solution. What we know is that we have 10 liters of the 50% solution. We do not know how many 40% solution, and we do not know also the quantity in liters of the 90% solution. So that is now where we assign a variable. We let x be the amount of 40% solution of rubbing alcohol in liters. So we let this to be x. This is our choice for the variable x because the question itself says how much 40% of rubbing alcohol do we need. And if we find x, that will give us the quantity of the 40% solution, which is the answer to the problem. Now, the total of these two is 10 liters. If one of the solutions is x liters, that means the other one must be 10 minus x, so that when you add 10 minus x plus x, the result is this 10 liters. Then multiplying the strength and the volume, that will give us the liters of pure alcohol. So 0.90 times 10 minus x is the pure alcohol for the 90% solution. Do the same thing for the rest of the mixture. We have here 0.40 times x, and we have here 0.50 times 10, which is equal to 5. Now the next step is we need to form an equation. The equation is coming from this last column because the liters of pure alcohol in the 90% solution plus the liters of pure alcohol in the 40% solution will give us the total number of pure alcohol in the combined solution. So you add these two rows, the result must be equal to 5. So again, this is the liters of pure alcohol in the 90% solution. This is the liters of pure alcohol in the 40% solution. When added, that gives us the liters of pure alcohol in the combined solutions with a strength of 50% alcohol. All there is just solving this algebraic equation. We have a monomial factor times a binomial. Let's apply the distributive property of multiplication over subtraction. Then copy all the rest. Combine like terms, we have negative 0.90x plus 0.40x. This gives us negative 0.50x. Then copy all the rest. Then we add 0.50x to both sides of the equation and subtract 5 from both sides of the equation. The result is 9 minus 5 equals 0.50x. This one goes here, it's now positive. This 5 goes to the left, but it is now negative. 9 minus 5 is 4, and copy all the rest. Then divide both sides by 0.50 to arrive at x equals 8. So this x now is this 8. So this means that the volume of 40% solution is 8 liters. This is now 8 liters. And since the total volume here is 10, if this is 8, this must be 2, or 10 minus 8 equals 2. Then this x is this 8. So 0.40 times 8 gives us 3.20. This 10 minus x is this 2. So we have 0.90 times 2, or 1.80. The sum of 1.80 plus 3.20 is 5.00, or this 5 liters, which confirms that our solution is correct. So for our final answer, how much 40% rubbing alcohol do we need? We need 8 liters of that solution. Our final answer is 8 liters. And so, that is where the math is.